Hello, I'm going to present our research on security debt, characteristics, product lifecycle integration, and items. As you know, not only personal devices are highly and continuously connected, also cyber-physical systems and critical infrastructure can be subject of important security threats. In our team at Tecnalia, we are in a research project trying to create trust in the industrial digital transformation. Within this trusting project, the topic where the authors were involved the most is in trying to bring technical debt management to security aspects. One of the initial contributions we wanted to make is to provide insights on the intersection between security and technical debt by analyzing the existing literature. This way, we found responses to a set of questions that were useful for us, and we expect them to be also for the community. Being security debt an incipient field, how can we define security debt and which are its most salient characteristics? How is security debt management introduced in the product life cycle? Which examples of security debt items are described out there? Regarding methodology, first we designed a focus query for the Scopus digital library on the mentioned intersection, mainly for technical debt publications mentioning security aspects. This returned 67 entries. After some filters described in the paper and snowballing readings, 22 publications were identified as primary sources. Then we performed a coding step where we assigned codes to entities that we consider that they've responded to the research questions. This way, the codes are like three categories that we identified. In the paper, you had details of the distributions per year and in the venues or journals of these primary sources. For the definitions, most of the works did not try to define it, but we observed certain underlying consensus. The summary of our team is that security debt refers to the completeness and correctness of the solution that the development team is creating in terms of the needed security characteristics and requirements for the future operation of the system in the expected operational context. It is incurred intentionally or unintentionally when limited approaches or solutions are applied to reach the needed security levels. As a consequence, we can compare traditional technical debt with security debt, saying that what we accumulate is not additional work for maintenance, but security risk. Besides the definition itself, the characteristics that we identified provide more insights on the topic. We group the characteristics in technological, organizational, and one category about its consequences. The numbers on the right are the number of primary sources. So if you are interested in a particular aspect, you can check the paper for the concrete references. In technological characteristics, security debt can be present in different artifact types, requirements, design model, source code, and so on, pretty much as in traditional technical debt. Security debt and security risks are closely tied. Security engineering, verification and validation, as well as continuous security engineering, helps to identify and avoid unintentional security debt. Then, technical debt can be a source of security debt, and trade-offs of security and other quality attributes, such as performance, might force to assume security debt. In organizational characteristics, we have that it is recommended that organization policies prioritize security debt. Security awareness and skills are needed to avoid security debt, and security debt involves different stakeholders, and decision-making among them is usually required. Finally, as consequences, the interest of the debt is high, creating significant business damage. The interest will be paid mainly when someone exploits the vulnerability and not before. And paying the principal of the security debt might, in some cases, require to change processes in the company. Regarding the product lifecycle integration and related to the previous technological category, all the stages disciplines are subject to generate security debt, requirements engineering, source code implementation, and so on. Identification of security debt is a continuous process. We should not consider it a single-shot process at the beginning of the project. There are some proposals to extend security risk management to manage security debt, and risk assessment can be used to quantify and prioritize the items. Different activities can help to identify security debt, namely security verification and validation, assurance management, and traditional technical debt management through existing indicators. A couple of concrete instances of product lifecycle has been reported, one related to security DevOps and another one related to an existing cybersecurity framework extended with security debt management aspects. Regarding security debt items, examples can be found for almost all work products in the product lifecycle: requirements, risk analysis, abuse cases, architecture design, source code, third-party components, databases, physical parts, assets from verification and validation activities, conformity to standards and guidelines. Deficiencies or limitation in any of those assets can have implications on security. As conclusion, we consider that security debt management can contribute to a fundamental challenge in industry today that in the end might affect final users and society. And well, by identifying 22 primary sources in the literature, we categorize security debt most salient characteristics, product lifecycle integration, and types of security debt items. We think that sharing these insights with the community and providing quick reference to relevant works for those which are interested in a particular category can help to advance this field in a more aligned way. As perspectives, we would like to mention a few observations we made. We were missing the tail experience report or some kind of dataset. We missed tooling and more discussions about how security by design principles can help to alleviate security debt. As further work from our side, we are defining a tool-supported quantitative method for security debt management in early stages. Thank you very much for your attention. Okay, hello everyone. My name is Javier Martinez from Tecnalia, and I'm going to present our research on security debt, characteristics, product lifecycle integration, and items. As you know, not only mobile devices are highly and continuously connected, also cyber-physical system and critical infrastructure are subject to important security threats. We are in a project where we are investigating the industrial digital transformation, and the focus is to bring technical debt management to security aspects. One of the main contributions that we wanted to make is to provide insight in the intersection between security and technical debt by looking at the literature. We were interested in a set of questions that we hope that that the results that we have are also interesting for the community. So the questions were: how can we define security debt and which are its main characteristics? How is security debt management introduced in the product life cycle? Which security debt items are present in the current literature? For this, the methodology was, we designed a very focused query, basically looking at technical debt publications where security aspects were mentioned. With this query, we retrieved 67 entries, and after some filters and snowballing readings, we end up with 22 primary sources. Then we have coding steps where we identified in the papers the entities, the parts that we consider that tries to respond to our questions. So what we report in this paper is like a set of 3 categories. You have more details of the methodology in the paper. We also report the distribution of the publications per year, the venues or journals where these publications were published. Most of the papers, they didn't try to define security debt, but we identified an underlying consensus on its definition. This is the summary that we made. Security debt refers to the completeness and correctness of the solution that a development team is creating in terms of the needed security characteristics and requirements for the future operation of the system in the expected operational context. It's incurred intentionally or unintentionally when limited approaches or solutions are applied to reach the needed security levels. If we want to compare traditional technical debt with security debt, well, in traditional technical debt, what we accumulate is additional work to evolve or maintain the system, while in security debt, what we accumulate are risks compromising the security. Apart from the definition, the main contribution of this work is the identification of the characteristics of security debt. We categorize them in technological, organizational, and consequences. Here on the right, you have the number of publications, the number of primary sources that are related to each of those points. So if you are interested in one of them, you just need to go to the paper and look at them. No? So in the technological aspects, security debt can be incurred through different artifact types, requirements, architecture design, source code, testing assets, etc. No, pretty much as in traditional technical debt. Security debt and security risk are closely tied. Verification and validation helps to identify an intentional security debt. Continuous security engineering as well helps to avoid an intentional security debt. Technical debt can be a source of security debt, and trade-offs of security and other quality attributes, such as performance, might force to assume security debt. In the organizational aspects, we have organization policies should prioritize security debt. Security awareness and skills are needed to avoid security debt. Security debt involves different stakeholders requiring discussions and decision-making among them. As consequences, the interest of the debt can be very high, representing high business damage. Interest will be paid mainly when someone exploits the vulnerability and not before. And paying the principal of the security debt might require to change processes in the company. Regarding how they introduce security debt management in the product life cycle, there are several works. And related to the previous point, technological aspect on the different artifacts that can be involved. Also in the product life cycle, we can say that all the stages disciplines are subject to generate security debt, requirements engineering, source code implementation, and so on. Identification of security debt is a continuous process. We should not consider it as a single shot activity in the beginning of the product life cycle of the project. No, it needs to be a continuous thing. Some approaches tries to combine security risk management with security debt management, and risk assessment can be used to quantify and prioritize the items. Regarding identification techniques, we have security verification and validation, assurance, and also technical debt indicators can help to identify security debt. A couple of instances has been reported, instances of product life cycles where we integrated security debt management, security DevOps, and a cybersecurity framework extended with security debt. Regarding the items, like the working products where we can incur the technical debt, we have, as I said before, we have requirements, risk analysis of use cases, architecture design, source code, third-party components, databases, physical parts, verification and validation asset, conformity to standards. So deficiencies or limitations in any of those assets on security, and therefore we can have security debt items there. We think that security debt management and the advance on this field is important and is to tackle fundamental challenge of industry today, and that at the end has also consequences in the society. In this work, we categorize its most salient characteristics, how it was introduced in the product life cycle, and the types of reported security debt items by looking at the existing literature so far. We think that the insight that we provide can help to have an aligned vision for future research, and also the reference, the pointers that we provide to the different points can be helpful for the researchers of this community. Some gaps that we have identified during this work: we were missing some experience reports and data set, more tool support, also a discussion of how security by design can help to alleviate security debt. As further work in this trusting project, we are developing a tool and a method for managing security debt in early stages, notably requirements engineering and risk management. That's all for this short paper. Thank you very much, and let's discuss if you have any doubt or any question. Thank you very much.
Thanks a lot, Javier. It was a very interesting presentation and topic. We have one question from Wesley, so I'm starting from the questions of the audience. So Wesley is wondering about security debt in the context of the technical debt quadrant, and technical debt based on reckless actions, decisions that might lead to catastrophic consequences.
Yeah, so good question, because security debt is also a very special. I think that is a special case also with regards to the speed of new vulnerabilities, new ways to attack the system. So an intentional security debt, it might be maybe more relevant than in other technical debt contexts, no? Sometimes you design your system thinking that it's very good, but maybe the next day or the week after or the year after, something will appear that is posing problems to your system. So unintentional technical debt is very present here. Yeah.
Thanks a lot. We have only 6 seconds, so I would like to encourage everyone who wants to continue the discussion to take it to the discussion room that Zad